Hey everyone, in this video we're going to be going over balancing reactions and classifying the reactions as one of the 5 types. So these are just some practice problems, but let's summarize those 5 types of reactions. So we have synthesis, which is the get together, right? Two elements or two particles coming together to make one new compound. We have decomposition, which is the opposite, the breakup. That is the type of reaction where you have one thing on the left, one compound, and it breaks apart into smaller pieces. We have single replacement. Oh boy. Single replacement. We have double replacement. Single replacement being when we have one element taking the spot of another in a compound. Double replacement when we have two compounds and they swap. And then the last one is combustion, when I have a hydrocarbon burning in oxygen. So those are the 5 types we're going to use to identify our reactions here. Here's our first example. C6H6 plus O2 makes H2O and CO2. So I'm first going to identify the type of reaction. So this is, if I look at what's happening here, it almost looks like the carbon now is paired with oxygen. The hydrogen is also now paired with oxygen. And my products are H2O and CO2, and I have this oxygen here. Plus, this is a hydrocarbon. So this type of reaction is combustion. Okay, so that's our identification. Now let's go ahead and try to balance. So I'm going to start by making my list of my elements. C, H, and O. I have 6 carbons on the left, 6 hydrogens on the left, and 2 oxygens on the left. On the right, I only have the 1 carbon, I have 2 hydrogens, and I have 1, 2, 3 oxygens. I'm going to go in this order. Okay, so I'm going to try to balance the carbons, then I'm going to balance the hydrogens, and then I'll leave the oxygens for last. I leave the oxygen for last because it's in its element form here, and so I can kind of put on whatever number I need to on that O2 to make sure things balance out. So to start with carbon, I need 6 carbons on the right to match the 6 carbons on the left. When I need to balance that, I need to think about the fact that CO2, each CO2 molecule has 1 carbon in it. So in order to match 6 carbons, I'm going to need 6 of these whole CO2 molecules. When I have 6 CO2 molecules, that's going to now give me a total of 6 carbons. So those are matching or balanced. I now also have 6 sets of 2 oxygens, so that's 12 plus 1, so I now have 13 oxygens. But again, that's kind of a wonky setup now, so I'm just going to leave that for the end. I'm going to move on to the hydrogens now. So I have 6 hydrogens on the left, and the setup for hydrogen on the right is water. Each water molecule has 2 hydrogens, so in order to match or to get 6 hydrogens on the right, I need 3 water molecules. When I have 3 water molecules, I have 2, 4, 6 hydrogens, and then I have an additional 1, 2, 3 oxygens. All right, well, this is going to end up a little fun. All right, so when I do that, that matches 6, and then I have 1, 2, 3 plus 12, so that's going to be 15. All right, so really, carbon's balanced, hydrogen's balanced, but this is not a really good situation. Oxygens come in sets of 2 over here. There is no way that I can match 15 oxygens with sets of 2. I could do that if I didn't use a whole number coefficient, if I used a coefficient of 7.5, but I can't do that. Our rules are that our coefficients have to be whole numbers. So when this scenario occurs, when I have, this coming in pairs and this being an odd number, I have to adjust this ratio. And remember, this is just a ratio. That's all it is. So what I'm going to do is I'm going to take each coefficient, and in order to make this even, I'm going to multiply by 2. I'm going to multiply each of them by 2. So my coefficients will then be 2, 15. This was a 3, right? So that's now 6. This was a 6, so this is now 12. Oof, that's a challenging one, but let's double check that we have all of the same number of each atom on both sides. 2 sets of 6 gives me 12 carbons. This 12 here gives me 12 carbons. 2 sets of 6 gives me 12 hydrogens. 6 sets of 2 for the water gives me 12 hydrogens. 6 oxygens from the water. 12 times 2 is 24, so that's 30. Oh my goodness, 30 oxygens on the right. 15 sets of 2 is also going to give me 30 oxygens on the left. So that's a bulky one, but that's it. Let's go on to the next one. All right, this is silver plus, this is actually hydrosulfuric acid. And then that produces silver sulfide and hydrogen. I have an element plus a compound, splits, and that A takes the spot. Right now I have AC plus B. An element plus a compound, that new element kicked hydrogen out of the compound and left it on its own. This is a single replacement reaction. So there's my identification. Now I can go through and balance. So I'm going to erase all this. I'm going to make my list. So silver, hydrogen, sulfur, and I'm going to count them up. 1, 2, and 1. 2, 2, and 1. The only thing that's not balanced right now is silver. So that's a pretty easy fix. I have 2 on the right and only 1 on the left. Well, I can put a 2 here to match the 2 on the right, and then I'm good to go. Remember, you can put your 1s here if you really want, but they're not necessary. You can just leave those blank. Moving on. This reaction, I have aluminum sulfate reacting with barium iodide, and I now have aluminum iodide and barium sulfate. I essentially have AB plus CD, right? Compound plus compound makes AD plus CB. That right there, folks, is a double replacement reaction. I can tell because I have 2 compounds and they are swapping partners. That is the clue for it being double replacement, swapping partners. So I'm going to erase this and make my list. So my elements are aluminum. Sulfate is actually the same on both sides, so I'm going to keep sulfate together. And then I have barium and I have iodine. Then I'm going to do my counts. 2 aluminums, 3 sulfates, 1 barium, 2 iodines on the left. On the right, 1 aluminum, 3 iodines, 1 barium, 1 sulfate. So we're a little all over the board here. I'm going to start with aluminum, just again, because it's just going to go left to right. I have 2 aluminums on the left. My aluminum on the right comes in this aluminum iodide form. So I'm going to need to add another one of these guys so I can match 1, 2 aluminums. When I do that, however, it's going to give me a total of 6 iodines. So my aluminums are balanced, but now everything else is still a little thrown off. So now if I look at sulfate, if I just continue to move down, I have 3 sulfates on the left and only 1 on the right. In order to match 3 sulfates, I can add 2 more barium sulfates, right? For a total of 3 of these formulas. So 1, 2, 3 sulfates. But that also gives me 3 bariums. So aluminum is balanced, sulfate is balanced, but you can see that my barium and my iodine are still a little off. Well, my barium and my iodine are partners on the left, and that's where I need to add some more. I actually need 3 of these things, right? When I have 3 of these, I have 1, 2, 3 bariums to match the 3 bariums I have on the right. And I have 2, 4, 6 iodines to match the 6 iodines I have on the right. So my coefficients here would be 1, 3, 1, 3. Remember to always summarize. If you're using this method of rewriting the formulas, make sure to summarize that with the coefficients in the blanks. All right, we have 2 more. This one is, let's start with identifying. I have zinc plus oxygen makes zinc oxide. Hopefully we can see that's an element plus another element to make a compound. So that is a synthesis reaction, right? Element, element, compound. Element, element, compound. So now that we've identified it as synthesis, we can go ahead and do our balancing. So we're going to follow the same procedure. List out the elements, count them up, 1, 2, 1, 1. This is decently simple. You only have 2 elements here. The only one off balance to start is oxygen. So if I add another zinc oxide over here for a total of 2 of them, it'll give me 2 oxygens, and it'll also give me 2 zincs. So oxygen is balanced. But now when I did that, because zinc and oxygen are a package deal, I also threw off the zinc. So in order to fix it, I'm going to go ahead and add another zinc over here for a total of 2. Right? I could write it in if I wanted. 1, 2. So 2, 1, 2. So that is how that one is balanced. And our last example here, I have silver nitrate plus copper yields copper nitrate plus silver. So this is a compound, AB, right? Silver nitrate plus an element makes a new compound. C is now, copper is now with nitrate, and silver is all by itself. Silver got kicked out of that compound. So this is another single replacement reaction. So now let's do our balancing. I have silver. I'm going to keep nitrate as one thing because it's the same on both sides of this reaction, and then copper. Count it up. 1 silver, 1 nitrate, 1 copper on the left, 1 silver, 2 nitrates, 1 copper on the right. The only thing that's off balance here is the nitrates. I need another nitrate on the left. If I add another nitrate, I will have 2 silver nitrates. So 2 silvers now and 2 nitrates. So nitrates are now balanced. Copper is still balanced, but I need to fix the silver. Lucky for us, silver is all by itself over here, so I can just add another one for a total of 2 of those guys to match 2. Hopefully, as you guys are working through more and more examples, you're able to kind of just not maybe use your chart as thoroughly and maybe not have to write out the elements and just be able to say, okay, well, I need 2 of these molecules to even this out. Again, you can put your ones or you can leave these lines blank. All right, I hope you found these practice problems helpful. Please let me know if you have other questions or need more help.